beauty pageant video presentation. But first, let us know the objectives for this wonderful event. First is to know the different types of reasoning. Second is to be able to validate statements and arguments made about mathematical concepts. And last but not the least, is to be able to write a comprehensive and analytical proofs. Moving on, you'll be witnessing the most unique and exciting mathematical pageant you'll ever see, with the theme of the significance and function of mathematical reasoning, and the title of Discovering Various Mathematical Solving, Reasoning, and Concepts. And today, let the show begin!
Excuse me, can I have your attention please for one more time? She tastes like cola, sweet, sweet sugar cola. When I took a sip from her lips, she sent me on a trip. She keeps me up at night and it's all because she cakes.
Candidate number 1, and my name is Rika May Ingusan.
Standing in front of you is a 20-year-old singer. Candidate number 2, Jacqueline B. Hyman.
Good morning, ladies and gentlemen. Candidate number 3. My name is Liberty A. Filipino.
A pleasant morning each and everyone. My name is Jose Fabiano. I'm candidate number 4.
Candidate number 5, and my name is Florini B. Jumabo.
Giselle Andoyo Villeneuve, candidate number 6.
Now, let's call our candidates for the question and answer portion. Candidate number 1, here's your question. What is reasoning in mathematics?
Thank you for that beautiful question. I believe that mathematics is not just about numbers. It is also about problem solving and reasoning. Reasoning is the act of stating ideas clearly and accurately in order to reach a conclusion. And then in the area of reasoning, we have a common term called conjecture, which refers to a conclusion reached after seeing and analyzing facts and arriving at a conclusion. The first type of reasoning is intuition, which is a type of reasoning that is similar to guessing, in that it does not require any pause or other actions, but instead requires you to supply reasons or statements that are similar to guessing. The second type of reasoning is analogy, which is when more similarities are inferred from a specific resemblance between two or more things.
Candidate number 2, please come forward. Your question is, what is inductive reasoning? Thank you for that wonderful question. For me, inductive reasoning is a process of reaching a general conclusion by examining a specific examples or observation. It is from specific to general, and it uses sequences, orders, and patterns. In this type of reasoning, it is more giving a probable conclusion. It shows the best answers on the past examples and observations. On the other hand, conjecture is a concluding statement that is reached by using a inductive reasoning. So now let's give an example of a conjecture in inductive reasoning. Study the pattern and determine the next figure. If we analyze this pattern, we base our answers on the each sides of shapes. The first shape is triangle and it has 3 sides. The second shape is a quadrilateral and it has 4 sides. The third shape is a pentagon and it has 5 sides. So our conjecture in this kind of pattern is the next figure will have 6 sides, and that is a hexagon. Moving on with our last example. Every year we get a thunderstorm in April, and since it is April, we will get a thunderstorm. In this case, we come up with a probable conclusion based on our past observations. And this is the meaning of inductive reasoning. Thank you, Miss Candidate number 2. And now, let's call Miss Candidate number 3. And your question is, what is deductive reasoning?
Thank you for that very beautiful question. Good morning to all of you. From what I have studied, deductive reasoning is very important in mathematical problem solving because deductive reasoning is a type of reasoning that uses procedures and principles to reach a conclusion. It is also a process that reaches a general conclusion by applying general assumptions, procedures, or principles. For example, use deductive reasoning to make a conjecture. Consider the following procedure. Pick a number, multiply the number by 10, add 8 to the product, divide the sum by 2, and subtract 4. Here's a solution. Let n represent the original number. Multiply n by 10 equals 10n. Add 8 to the product, and 10n divide the sum by 2 and subtract the quotient by 4. So, the answer is 4 plus 5n minus 4 is equals to 5n. Hence, the given procedures, a number that is 5 times the original number, or 5n.
We were down to 3 candidates. Next, we call on candidate number 4. And here's your question. What is conditional, hypothesis, conclusion, converse, and biconditional reasoning in mathematics?
Thank you for that fantabulous question. A conditional statement, also called if-then statement, the statement with a hypothesis followed by conclusion. Another way to define conditional statement is to say, if this happens, then that will happen. Now, I will give you an example. If you get good grades, then you will get into a good college. The part after the if you get good grades is called hypothesis, and the part after the then you will get into a good college is called a conclusion. Hypothesis followed by a conclusion is called an if-then statement or a conditional statement. This is noted as if P then Q. A conditional statement is false if hypothesis is true and the conclusion is false. The examples that I gave earlier would be false if it said, if you get good grades, then you will not get into a good college. If we rearrange the conditional statements or change parts of it, then we have what is called a related conditional. To explain this, I will give an example. If the population consists of 50% women, then the 50% of the population must be men. If we exchange the position of the hypothesis and the conclusion, we get a converse statement. If a population consists of 50% women, then 50% of the population must be men. If both statements are true, if both statements are false, then the converse is true. A conditional and its converse do not mean the same thing. A conditional statement is a logic statement that includes the phrase if and only if, sometimes abbreviated as if. Here is a conditional statement as a compound statement. If the polygon is a square, then it has 4 sides of equivalent and 4 right angles. And a polygon has 4 sides of equivalent and 4 right angles, then it is a square. The last statement was a true biconditional statement because it combines the conditional. If the polygon it is a square, then it has 4 sides of equivalent and 4 right angles. Then it's converse. If a polygon has 4 sides of equivalent and 4 right angles, then it is a square. It can be written out as a simpler biconditional statement.
Moving on, let's call candidate number 5. And here's your question. Can you differentiate what are the associate properties?
Thank you for a wonderful question. So property states that when 3 or more numbers are added or multiplied, the sum of the product is the sum regardless of the groupings of the addends or the multiplicands. Grouping means the use of parentheses or bracket to group a numbers. It involves 3 or more numbers but cannot use subtraction or division.
And now let's call our last candidate, which is candidate number 6. And here's your question. What are the mathematical proofs and how to write proofs?
So mathematical proof, a proof is a sequence of true facts or statement placed in a logical order. In proving, the following may be used as reason. So the given information or the hypothesis, definition and undefined terms, algebraic properties, postulates of geometry, previously proven geometric conjectures or theorems. Now, algebraic and geometric proof. In order for us to prove properly and correctly, it is wise to remember and understand the necessary properties to be used in writing formal proof. So, important of properties of algebra. For real numbers, W, X, Y, and Z. And reflexive, X equals Y. Symmetric, if X equals Y, then Y equals X. Transitive, if X equals Y and Y equals Z, then X equals Y. Substitution, if X plus Y equals Z and X equals 3, then 3 plus Y equals Z. Indistributive, X close and open parenthesis, Y plus Z equals XY plus XZ. Now, how to write proof? There are many ways on how to write proof. We can have top-down or deductive reasoning or bottom-up or inductive reasoning. So it can be formal or informal procedures. For example, this is the example. Prove the following using formal proof. This is the given and the statement and the reason. The reason is given, definition of midpoint, given, transitive. And I thank you.
And now, this is the moment of truth. Let's call the candidate for our first ever Miss Mathematics 2022. And our winner is candidate number 4.
It would be a great honor and a privilege to me to be a Miss Mathematics, and I just want to say that always remember, mathematical problem solving requires reasoning and complete proofs to justify and apply the correct answers or solutions. Solving mathematical problems also needs a lot of ways or approach or solutions, and it is not facilitated or used by numbers only, but also the capacity to think critically in any given situations or circumstances, to reason out or attest logically and solve problems intelligently. And lastly, mathematics is a big help or useful in our daily life. We cannot solve problems and reasoning without the applications of mathematics.